various basic algebraic skills such as distributive property, combining like terms, and then what it looks like to solve one step equations when you're given either addition, subtraction, multiplication, or division. All right. So for this is going to round up the basics of algebra before you start heading straight for the heart of basic algebra stuff. Okay. So what we're going to cover today is we're still working on expressions and equations, but we're going to focus on dependent and independent variables. Okay. So you're going to get various word problems, and then you have to establish, okay, which variable can I independently move? All right. That does not rely on the dependent variable, and which one's going to be a dependent variable. Okay. So couple things we need to talk about. What is a dependent variable in math? What is a independent variable in math? Okay. So dependent variable in math is a variable whose value depends on the values of one or more independent variables. All right. And then you're probably asking, well, what's an independent variable? Well, independent variable is a variable whose value determines the value of other variables. So independent, a good example of a independent variable is time. All right. Time, moves on its own. Okay. Everything usually depends on time. Time does not depend on anything else. Okay. So, like, if you're trying to figure out how fast you're running in a certain amount of time, your speed would be the dependent. Okay. So, your speed, nope, let me, uh, pen's, pen is struggling. So, speed would be your dependent, and then your independent would be time. Okay. So that just gives you a quick, example of what an independent and dependent variable is. Okay, we might see time again, we might not see time again. We'll see. All right. So let's take a look at an example. All right. So tickets for the school musical are $8 per ticket. This table, okay, this table right here shows the total cost, or C. All right, cost will be represented by C for a certain number of tickets, T. Okay, so cost is C, number of tickets will be T. All right, so we're going to complete the table and describe the relationship between a total cost and tickets purchased. Okay, so tickets are on the left hand side here, and the total cost will be on the right hand side. All right, so in the example above, the total cost of tickets, or C, depends on how many tickets are purchased. Okay. An equation representing the relationship between T and C looks like this. So total cost equals 8 times T. Remember, in algebra, the basic default operation is going to be multiplication. All right. So anytime you see a number next to a variable, it can also be looked as this. Okay. I'll even write it second way. So C equals 8T, or C equals 8 times T. All right. So total cost, all right, total cost is going to be dependent upon the number of tickets. All right. So number of tickets dictates total cost. Okay. So the total cost equals 8 times the number of tickets purchased. Remember, it's $8 per ticket. Okay, so each ticket's going to cost $8. So one ticket sold, total cost would be $8. If two tickets are sold, the cost will be $16. Three tickets are sold, cost will be $24. Four tickets are sold, cost will be $32. And five tickets are sold, cost will be $40, and so on and so forth. Okay, so it's essentially multiples of eight. Okay, so number of tickets, or T, is the independent variable. The total cost is the dependent variable. Okay. Example 2. So let's take a look at it, some examples. All right. So Marcus reads 30 minutes each night. He wants to determine the total number of minutes he will read over the course of a month. He wrote the equation T equals 30D to represent the total amount of time that he has spent reading, where T represents the total number of minutes read and D represents the total number of days that he read during the month. Determine which variable is independent and which is determine which variable is independent and which is dependent. Okay. My apologies for that typo. Then create a table to show how many minutes he has read in the first 7 days. Okay, so what we have to do is we have to determine, all right, which one is the number, which one's the independent, which one's the dependent, and then go ahead and fill out this little chart that's been made for us. One thing that we know immediately, okay, is using the equation Marcus came up with. He has dictated that total of minutes in the month is going to be, so he's reading 30 minutes a day. D is going to be number of days, and total time is how much time he read during the month. Now, if you recall at the beginning of this video, I had mentioned time being always being a independent variable. Okay. In this case, all right, time is going to equal number of days. All right, because days is a form of time. All right, you have seconds, minutes, hours, days, weeks, years, months. Okay, so in this case, independent variable is going to be number of days. And because the independent variable is going to be number of days, the dependent variable, all right, is going to be total minutes read. Okay. Because so number of days, it's going to constantly change. It's going to change regardless. In order for how many minutes we read in a month, it's going to be dependent upon on how many days are in that month. Okay. Because every month does not have the same amount of days. Okay. So now what we have our two variables, what we have to establish is our little chart here. Okay. So if we read for one day, okay, if we read for one day, we'll substitute. I'll put it right here. All right. So we still have our equation, right? T equals 30D or T equals 30 times D. All right. So instead of D, I'm going to put 1. All right. 30 times 1 is 30. Okay, what if I put, instead of 1, I put a 2? All right, for 2 days. So in 2 days, 30 times 2 should be 60. So in 2 days, Marcus should have read 60 minutes. What about 3? 30 times 3, 90. 4, 30 times 4, 120. 5, 30 times 5, 150. Okay, so there is our table to show how many minutes he has read in the first 7 days. Okay, so we still got to go through 7 more days, even though we only have 5 layers. So 30 times 6 equals 180. 30 times 7 equals 210. Okay, so now that we have our table to show how many minutes he has read in the first 7 days, we have our independent variable of number of days and our dependent variable of total minutes read. We have established for Marcus, okay, his independent variable, his dependent variable, and figure out how many minutes he's going to read at night in the first 7 days of a month. Okay, let's take a look at another example. Okay, Kira designs websites. She can create 3 different websites each week. Kira wants to create an equation that will give her the total number of websites she can design given the number of weeks she works, determine the independent and dependent variables, create a table to show the number of websites she can design over the first 5 weeks. Finally, write an equation to represent the number of websites she can design when given any number of weeks. Okay, so this one's going to be a little bit more challenging only because we have to find the equation. However, back in when we were looking at solving equations in the first video, I had you watch a video uh, from Khan Academy writing algebraic expressions anytime you're given a real world problem. So that's going to be a carryover, all right, from that skill into this video. All right. Now, you're not always going to get this situation. However, one thing I do want to point out is anytime you're given a chart, all right, anytime you're given a chart, your independent variable tends to always be on the left hand side, and your dependent variable always tends to be on the right hand side. Just a little key point, all right? So we've already established, so we can go ahead and establish our independent and dependent variables immediately out of the gate, all right? Uh, but just in case you don't get a chart, remember time. Time is generally a great starting point for independent variables. And this time, okay, Kara wants to create an equation that will give her the total number of websites she can design given the number of weeks she works. All right. So looking at this, all right, number of weeks worked, number of weeks Kara's worked is going to be our independent variable, if I can write. And then our dependent variable is going to be how many websites she's actually designed. Okay. So now that we've got that, okay. So in the word problem, it says that she can create 3 different websites each week. All right. So if Kara works 1 week, she can create 3. If she works 2 weeks, all right, how many do you think she's going to be able to make? 6. All right. Here's why. Okay. So one thing that I'm seeing, all right, is for the first week, she made 3 websites. So if we keep up that same pattern, all right, it's going to be so she's going to be able to design. So she's going to be able to design 3 websites for every week she works. Okay. So it's going to be number of websites designed equals 3 every week. Okay, so if she works 2 weeks, she should have 6 done. If she works 3 weeks, she should have 9 done. If she works 4 weeks, she should have 12 done. And if she works 5 weeks, she should have 15 done. Okay, and all I did, okay, and you're probably going, Mr. Reed, but you just wrote the numbers in the table. What mathematical craziness did you pull? Well, here's what I did. All right, taking the equation that we are able to pull out of the problem, all right, which in this case is number of websites designed equals 3 every week. All right, all I did was instead of W, I put number of weeks worked, just like we did in the last practice problem. Okay, so instead of 3W, I did 3 times 1 for 1 week worked. 3 times 2 for 2 weeks worked, 3 times 3 for 3 weeks worked, 3 times 4 for 4 weeks worked, and then 3 times 5 for 5 weeks worked. Okay. And which that actually answers our question for Kira. All right. Now that we have the table, we've created a table to show the number of websites she can design over the first 5 weeks. We have our independent variable, we have our dependent variable, and we have our equation. All right. So, all right. So that is independent and dependent variables when you are considering word